Welcome to day 7. In your planners, please be putting day 7 down. We're going to do the warm-up together. So for the first one, we basically just want to write what is this notation really representing. So P is for probability, so we want to find the probability that someone likes music given they are in 10th grade. So essentially, we know already that they're in 10th grade, and out of the 10th graders, we want to see what's the probability that someone likes music. So if you've got a two-way table, the way we would go about finding this probability is we would only look at the 10th grade. And I'm going to write row/column because we wouldn't know if 10th grade was in a row or a column without actually seeing the table. But you focus in only on the 10th grade row or column, and using only that row or column, find the probability of likes music. So if you've got one of these conditional probabilities, you should not be picking out any numbers that are not in that 10th grade row or column in this case. All right, moving over to the homework. So we had 49 received flu vaccine, 63 did not. And then we also have people that either got the flu or didn't get the flu. So in our two-way table, I put got flu and no flu along top with the total, and then received vaccine, no vaccine, and total on the left. You could have put the vaccine stuff on the top and the flu on the left. That's fine as well. So 63 people did not receive the vaccine, so that's how we got the 63 here. 49 people received the flu vaccine, and we can add those together to get this 112. They told us that of those who received the flu vaccine, 16 people got the flu. So in the receive vaccine row, we would have 16 that got the flu. Well, if you do 49 minus 16, that gives us that this spot is 33. Of those who did not receive the vaccine, 17 got the flu. So that's how we get the 17 here. 63 minus 17 would give us this 46. And if you just add straight down, that's how we got the totals for each of those columns. If a person chosen got the flu, so that means we want to focus only on the got flu column. What's the probability of no vaccine? Well, 17 out of 33. What's the probability the person did not get the flu and got the vaccine? So ands, ors, and individual probabilities are always out of the overall total. That's why we got the 112 in the denominator. And we're looking for a box that is no flu, yes vaccine. So the box that at the same time would be no flu and yes vaccine would be this 33. So that's why we have 33 out of 112. Moving over to number 2, they did not give us the totals. So you've got to find the totals of each row and each column, and then the overall total. First one, traveling and not checking a bag. Well, ands, ors, and individual probabilities are always out of the overall total. That's why it's over 1,000. Then just look for the box that represents traveling and not checking baggage at the same time. Well, that would be this box here. Traveling and no baggage, so 387 for the numerator. Next one, we already know that they're traveling for business. So that means we should only look at the traveling for business row, and from that row, find the probability of no baggage. So no baggage would be 387 out of the total for that row of 490. In C, we have the passengers not traveling for business. So we already know that to be true, so focus only on the not traveling for business row. From that row, what's the probability of no baggage? Well, 294 out of 510. For 3, we had to find the totals again for each row and column. So we want, this is an implied and. So the things we want is to be on time, and it has to be from LA or Seattle. So the boxes that are on time and being LA or Seattle would be these ones there. If you add them up, you get the 2338. And ands, ors, and individual probabilities are always out of the overall total. So that's why it's out of the 3775. Flight is delayed. Well, that's a single probability. So it's out of the overall total. And then our delayed ones are the 501. Delayed and from Phoenix, well, ands are out of the overall total, so 3775. And then a box that is delayed and Phoenix at the same time would just be those 12. So the 12 over 3775. And then we have 2 conditional probabilities to finish off. So we have San Francisco given it's delayed. So we're going to look at only the delayed column. And from that column, find the probability of San Francisco. Well, that's 102 out of 501. Then in E, we want the probability that we're on time given we're from San Diego. So we're going to look at only the San Diego row, and from that find the probability of on time. So here's San Diego. Probability of on time is 212 over 232. All right, we are going to be starting on packet page 45 today, and we will need calculators out. So please take a moment to get each of those things out, page 45 and calculators out. So today we're going to look at tree diagrams. Tree diagrams, they show all of the different outcomes you could have, and it also shows the probabilities at the same time. So what we're showing in this first one here on the top of page 45 is two coins being tossed. So you start your tree diagram at some point, and then you branch off with the outcomes for the first event. Well, the first event was head or tails. There is a 1/2 or 0.5 chance for each of those. So that's why you have 0.5 along the branches, and then at the end of the branches you have H and T. So now event 2, we're flipping again. So we've got 2 branches off of each of those of head or tails. You could have had 0.5 for each of them. And then what we're going to have you do is we're going to have you find the probability of each path. So if we were to follow this path, a head followed by a head, you just multiply those 2 probabilities. 0.5 and 0.5 would give us 0.25. Then our next path, we would go head followed by tail. 0.5 times 0.5 also gives us 0.25. And similar idea for each of the others. They end up as 0.25 for each of them in this case. It's not always going to be the same. It's just because each branch had 0.5 as the probability. Now that's the way we'll do it. You could also say that this branch here is really probability of heads given you already had a head. probability of tails, given you already had a head as well. But that, I think, is a little bit more confusing way to think about it. All right, if we go to the next page, page 46. So if a woman in her 20s gets screened for breast cancer and receives a positive test result, what is the probability that she does not have breast cancer? Well, so the woman gets a mammogram, and the probability she has cancer, they're telling us, is the 0.0004. No cancer is 0.9996. And then if you have cancer, they give us the probabilities of a positive or a negative test. Same idea if you have no cancer, positive or negative test. Well, what we want to do now is we're going to find the probability of each of these. So in our calculators, we want to multiply the 0.0004 and the 0.8. So we'll give you a moment to punch that in. So do the 0.0004 times the 0.8. And the calculator should be saying 3.t e negative 4. Well, that's really scientific notation. That's saying 3.2 times 10 to the negative 4. Negative exponent means you got to move it to the right. It should be actually a really small number. So 1, 2, 3, 4 to the right. These will be zeros, so this is really 0.00032. Our next path, we'll do the 0.0004 times the 0.2. So take a moment to punch that in your calculator. And we should have gotten 0.8 e negative 4 for that. So we've got to move this 4 to the right. So we get point and then 4 zeros and 8. Well, notice if you added those two together, you would get 0.0004, what the entire branch was. So multiplying the other branches, we would get 0.09996 and 0.89964. So from that, we can answer the question now. We want to know what's the probability that she doesn't have breast cancer if she received a positive test result. So first we want to identify any of the paths that had a positive test result. And that would be this one here and this one here. So if we add those together, that will give us our denominator. So if we do 0.10028 is what we would get if we would add those together. Now our numerator is, of those ones we boxed, which is what we actually want. So the denominator was all the positive test results. We want what's the probability she has breast cancer. Well, of those two, the cancer branch was the 0.00032. So take a moment and divide those in your calculator. And we should get a pretty long decimal. But this question did not say anything about rounding. So we would want to switch that back to a fraction. To switch a decimal back to a fraction, we want to hit Menu, Number, and then Approximate to Fraction. It'll have a weird looking command, but if you hit Enter, it'll switch it back to a fraction for you. And we should get 82507. And again, we put it back as a fraction because we got a decimal and it did not tell us where to round to. So that's the general idea of what we're going to work on today. So we're going to do a bunch of practice examples for that. So if we move on to page 47 now. And we'll give you a minute or two, see if you can read through all of that information there. So the two events we have are the group that they're in, A, B, or C, and then whether they have an accident or not. So the first thing we want to do in part A is to draw a tree diagram. Well, we're going to put it in the space that's above that. So in between the wording and above where it says draw a tree diagram, that's where we're going to put this. So start with a dot, and we need 3 branches. And our 3 branches will be A, B, and C, because that's what we did first. We split into the groups. Well, the probability of being in Group A, they told us it was 22% of its policyholders, so we'll have 0.22 here. The probability of being in Group B was 43%, so we'll have 0.43 along that branch. And then Group C was the rest of them. Well, 22 and 43, that'll give us 65%. So the remaining percent is 35% because we have to add to 100. Well, now, in each of these groups, either they had an accident or they did not. So let's do 2 branches off each, and we'll do ACC for accident and no ACC for no accident. And we'll have those 2 options for each group. So our probabilities, if you were in Group A, 11% at accident. So we'll have 0.11 here, because that's 11% as a decimal. Well, if 11% had an accident, since they have to add to 100%, that means 89% did not. So we'll have 0.89 for no accident. In Group B, we had 3% that had an accident. If you're not sure of what's meant by respectively, they did B and C in that order, so then the percentages are in the corresponding order. So B's percentage comes first, C's comes second. So we have 0.03 for B's accident. If 3% had an accident, that means that 97 did not, so 0.97 there. C's accidents were 0.02, because 2%, meaning 0.98, did not have an accident. Well, now what we have to do is we've got to multiply out our probabilities so we can find the probability of each branch. So the first one, we would follow A and then go to accident. So 0.22 times 0.11 should give us 0.0242. What we're going to do is we're going to pause the video for 2 minutes, see if you can find those other 5 probabilities. All right, so check those probabilities, see if you're in agreement with them. So we already drew the tree diagram. Part B, what percent of the company's policyholders are expected to have an accident during the next 12 months? Well, we've got to see which branches are the accident ones. Well, we had accident ones here, here, and here. And I'm just going to put our work for this right on this slide so I don't have to flip back and forth. You guys have it all on the same page, so you can put it right under where it says B. So all we've got to do is add those up, because these are all the different ones that had an accident. When we add those up, we get 0.0441. If it just asked for the probability, we could leave it like that, because probability could be a decimal, a fraction, or a percent, but they specifically asked us to switch it to a percent. So we've got to move our decimal over 2 spots, so that's 4.41%. Well, in part C, we want to know what's the probability that someone is under 25 given they had an accident. Well, whatever we're given, that should lead us to our denominator. We already found the probability of having an accident in part B. So that 0.0441 becomes our denominator. And then it says we want to know which of those are under 25. Well, of those 3 arrows we have there, the one that's under 25, that was group A. So that 0.0242 is what goes in the numerator. So this question C, you will see something on this, like this on your test, and it's one of the most commonly missed questions each year. So let's just recap where this came from. In part B, they had us find the probability of an accident. Well, because we were given that we wanted them to have an accident, and then the probability of those that had the accident being under 25 in part C, our answer for part B just goes as the denominator. Then the numerator in C is, of those 3 we added up, which one are we really working with? Well, we're really working with the under 25, so that's why the 0.0242 goes there. So take a moment and divide those in your calculator. So that probably did not come out nice. It does not tell us where to round. So we want to switch that to a fraction. So after you get your long decimal answer, again, do menu, number, and approximate to fraction. When we do that, we should get 242 over 441. Moving on to page 48, we'll give you a moment to read through the scenario there. So the things that we have a jelly bean that is picked, and then a second jelly bean is picked, but because the first one was eaten, it will not be replaced. So let's start with a point, and we have 3 flavors of jelly bean. We have lemon, watermelon, and raspberry. So let's abbreviate those with L, W, and R. Well, our probability of a lemon, we had 16 out of, if we added those all up, there would be 36. Probability of a watermelon would be 12 out of 36. And then the probability of a raspberry is 8 out of 36. Well, then in our second event, we're picking another jelly bean. So we want 3 branches. And in each case, you could have lemon, watermelon, or raspberry. Well, if you ate a lemon to start out, we now only have 15 lemons left, and there's only 35 total jelly beans left. For our next probability, the lemon then watermelon. So if we ate a lemon, we still have all of our watermelons left, so that's 12. But the lemon got eaten, so there's only 35 total. And if we ate a lemon and now want a raspberry, we still have all 8 raspberry, but because the lemon was eaten, there's only 35 left. So doing a similar idea with the others, If a watermelon's eaten, we still have all of the original lemons, and there's 35 left. If we ate a watermelon, we're now down one watermelon, and there's 35 total left. And if we ate a watermelon, we still have all 8 raspberry, and there's 35 left. And then doing a similar idea for the last one, and I'm gonna extend my branches into the other question just so I have a little more room. So this was lemon, watermelon, raspberry. So raspberry followed by lemon, we should still have all 16, but 35 total left. All 12, 35 total left. And then for the raspberry's missing, and there's 35 left. Well, now we've got to find the probability of each branch. So first we would do lemon followed by lemon. So we do 16 over 36 times 15 over 35, and that's going to give us 4 over 21. Then next we would do lemon followed by watermelon. So 16 over 36 times 12 over 35, and that would give us 16 over 105. And these fractions, some of them reduce, that's why they don't all have the same denominator. So then if we kept doing that, multiplying the branches, the next one would be 32 out of 315. We'd have 16 out of 105. 11 out of 105. 8 out of 105. Then going to the raspberry ones, we have 32 out of 315, 8 out of 105, and raspberry followed by raspberry. We would have 2 out of 45. So it's a little bit time consuming to find all those probabilities, but the purpose of it, it makes our follow-up questions easier. What's the probability that Juan eats 2 lemon jelly beans? So we're just looking for lemon followed by lemon. Well, here's lemon followed by lemon, so that's just 4 out of 21. So that question was easy because we already did the work. Part C, what's the probability that Juan eats a watermelon and a raspberry in either order? So we're looking for either W followed by R or R followed by W. Well, here's our W followed by R, and R followed by W is right there. So they're both 8 out of 105, so when we add those together, we would get 16 out of 105. And where that's coming from, again, we just added the two options together. If the first jelly bean selected was lemon, so we're basically already down the line. We're already here. We know lemon is for certain. So if we're just starting from this black dot, the probability that the second will be lemon is just 15 out of 35. Another way of thinking of it is, well, if we already know the first one's lemon, the probability of that first branch is 1, and you're just doing 1 times the 15 out of 35. And this does reduce if you wanted. You could reduce it to 3/7, but in probability, that's the one case where we often don't reduce. All right, we'll look at one last example quickly. So in the softball playoffs, a double elimination system is used. Screwballs are in the playoffs. 60% chance of winning the first game, then a 50% chance of winning their second game. If they lose the first game, then they go to the losers bracket. They have an 80% chance of winning that game. So really, there's basically 2 games that are being played. Those are our 2 events. So let's start with a point. The first game could be a win or a loss. We had a 60% chance of winning the first game, so this would be 0.6 or 0.60 if you want to write it. If it's 60% chance of winning, that means that's a 40% chance of losing. Well, now for the second game, in each instance, we could have either a win or a loss. So if they won the first game, then there's a 50% chance of winning the second game. So this would be 0.5. If it's 50% there, losing that second game would be 50% if we had had a win. But they said if we lose the first game, there's now an 80% chance of winning the second game, meaning this option would be 20% because they have to add to 100. We would need to multiply out our branches. So first we would do win followed by win. 0.6 times 0.5 would end up giving us 0.3 or 30%. And if you punch the other ones in, you'd have 0.3, 0.32, and 0.08. Well, now for the follow-up questions. Okay, this is just the option of if you did conditional probability, so we'll skip over that. So now the follow-up questions, what's the probability the Screwballs will be undefeated in the playoffs? Well, that means they won both games. Winning both games was that option there. So we just had 0.3. What's the probability they will win only one game? Well, that means they either won and then lost, or lost and then won. So that's those two options. If we add those together, we get 0.62. What's the probability they'll win at least one game? Well, we already know 0.62 is winning one game. 0.3 is winning two games. So altogether, they're going to have a 92% chance, or in other words, 0.92, that they win at least one. And what's the probability they will lose both games? Well, that's a loss followed by a loss. That was 0.08. So having all those probabilities from the T-chart make any follow-up questions a lot easier. So that's it for this video. Have a great rest of your day, and you've got the day 7 for homework.